And I believe we are live, ladies and gentlemen. Welcome back to the Gaming Nerd. It's another late night session. I have randomly decided to stream some Barotrauma. We're going to be working on a reactor data logger. There's been a recent update. Everybody knows Hoist the Sails, and they've really changed the way the reactor control works. So the old 2 or 3 component reaction controller is no longer viable, or not. I'm not going to say that it's not viable. It's just not the best anymore, and we're going to figure out some way to determine whether this is true one way or the other. And it's hung already. That's awesome. Now here we go. Big red text. That's off to a great start. Alright, normally I would start with a pre-made sub, but I think we should, it's been so long that we're going to start from scratch this time and see what we can do. It doesn't have to be a sub, we just need a box. So we're going to take some, make a ceiling, make a floor, flip that over, put some of these little end caps on the end there. Another one there, flip that around. How does that look? It looks terrible, doesn't it? Yeah, not bad. That's better. I know, attention to detail. My ex called it my attention to OC detail. So, anyways, we're going to start by making our box. Doesn't have to be a special box, just has to be a box that can keep the water out and keep you in. Yeah, really, that's all there is to it, isn't it? Okay, what do we got? Gotta go down one bit. And there are certain minimum requirements to a sub. You need to have a hull, of course. More than one's better. Do we need special walls? No, we don't. We'll just use these 90-degree guys here. And I guess in the process we're going to talk about or discover what the bare minimum of requirements are for a submarine in Barotrauma. It'll tell you as you go. It's got pretty good pop-ups. The developers for this game are on point when it comes to commenting and helping people who want to improve the game or just fuck around with it. Pardon my French. Okay, so this will be our reactor testing containment unit. We need a hull. Yeah, Barotrauma doesn't like the home key. I don't know why. Okay, I don't know why this thing pops up every time. Okay. Alright, next up is we need an oxygen generator. We're going to totally cheat. We're not going to put a reactor in, like with fuel. We're just going to put this oxygen generator down here in the corner. And we're going to go into the parameters here. And we're going to say this thing requires 0 energy for the lights and 0 energy for the oxygen production. Let's just boost this up a factor of 10. Doesn't really make a difference on this space, but we don't want to go dying of oxygen starvation anytime soon, do we? Alright. Back here, large platform. We're going to put this, we'll have all our little facilities here. We're going to have, technically speaking, we should have a ballast, but I just use the lock command as soon as I start up a test on something like this, and then there's no real need to worry about it. We'll put a ladder in, put a ladder in here, so if something happens that our dumbass presses the down button, we can get back up. Yeah, see, even that's not too big. We got this one. We'll put another one over here, I guess. Okay. You're going to want to turn hulls and links and not wires. We'll leave wires on. And you're going to want to turn off walls and structures as soon as we have some stuff down, because having to avoid picking the back wall is annoying over time. So we're going to leave it for now. We're going to say some sort of just generic background. Don't really care. Metal wall sounds good. Let's make it bigger. Yeah, looks fine. Let's light it up with the. It's a platform there. Okay, now let's pick a reactor. It doesn't matter which reactor we picked. Its end result's gonna be the same. I like this big bastard. You don't see him very often, so we're gonna put him in. You know what? This wall's gonna give me a tumor. I'm just gonna turn that down. There we go. Okay. Like I said, we're gonna see the way it lights up orange. It means you're picking it. So we're gonna turn that off so we don't have to look at it later on. Alright, every reactor needs a junction box. I don't know when they're going to fix that, but last time I checked, there's only one thing allowed to be connected to the reactor. It had to be a junction box. So we're going to put put it up over here. And then we'll just, for poops and giggles, we'll connect it to the power out here. Now, for those of you who didn't see me going over here to the wire controls, if you're new to the wiring editor, well, the whole submarine editor, you have to be in wiring mode in order to make connections like this. So there's edit mode and there's wiring mode. You can press Control 1, Control 2 if you want to switch between them. I'm lazy and unsophisticated, so I usually go up here and just click the wiring mode. However, I am not a barbarian, and I use numeric hotkeys to select my wires. So if you'll notice the hand here, cursor has a wire selected. If you press 1, the list is over here, right? White, red, blue, black, brown, green, whatever. That's 1, 2, 3, 4, 5, 6, 7, etc. What is that? That's probably a wrecked wire. I don't know. It doesn't matter. I usually use 3 for everything. Don't ask me why. 2 if there's power sometimes. But red and blue are pretty much all I use. I use the occasional white and black wire. When you're making a connection, so we'll disconnect this here. We'll just wiring mode. Okay, so here's the deal. You gotta have your screwdriver equipped, otherwise you can't wire shit. You go to wiring mode, hover over what you want to wire, you press E. Okay, this brings up this panel here. This is the connection panel. If you don't have the wire screwdriver selected and you press E, you open up the actual panel for assuming it's something that can be interacted with. So you want to be in wiring mode. When switching to wire mode automatically equips your screwdriver. You're going to go here, you're going to press 2 for a red wire. And see this grid line here? Where you've placed the item determines where the start of the wire comes from. So it's not necessarily always going to be dead on these grid points. But once you're in here, your wire is going to move to half grid snap points. So you can see you can go in on the lines, right? The intersection of the gray lines. Or you can go halfway in between. Or you can go half and half and come out in the middle of these squares. So either way, if you want to keep your wiring nice and organized, it's usually beneficial to leverage those lines. You can go in and move these nodes later. To create these nodes when you're running a wire, I'll disconnect this again. So you press E, you press 2 to red wire, you drag the ring to the port you want to connect to, and now the wire follows your mouse. If you left click anywhere that's not an object that can be, left click anywhere, it just drops the node, right? You can, and it doesn't matter how far it is from the last node, there will come a point, I think it's like 200 meters, is when it craps out. Anyways, it always drops a node as close to the cursor as possible that's still on those half snap grid points. If you press right click, no matter how far away you are from the node, it deletes the last made node. So I'm right clicking here and you can see it's working backwards one by one by one by one by one by one. Now, if you wire something here, let's just say straight to it, okay, and then we go back and we pick this up and we move the wiring and we move this junction box around, the wiring will follow, okay? If you add nodes to the wiring, you can place them once it's by pressing control left click when you're editing the wire, and you can create nodes that can be then later on added, or you can right click on the nodes to get rid of them again. So anyways, if you move the junction box now, it only moves from the last node, okay? Once you move the root or the terminal nodes, right, if I move this one here, okay, watch what happens. Nothing happens. I've broken the connection between the object and the wire. The wire still makes a connection. If we look in this thing, the red wire is still there. But the terminal node has been moved and is no longer directly tied to the movement of the sprite. So, that's a pain in the ass. We're going to switch that. We're just going to go back here. We're going to get rid of this wire, and then we're going to rewire from here to here. We'll fix it up and make it all pretty like later. Lower than the recommended bitrate. Oh well. I wasn't expecting anybody to come into this chat. I know it's been forever since I posted something. I've been working on something real nice for you guys. Hope you fucking appreciate it when I'm done. Okay, so we're going to leave that there. You need to create a load. Basically what we're doing here is creating a load for the reactor. Doesn't matter what you tell the reactor to do. If there's nothing for it to power, then it doesn't really do anything. And we have these lamps here. They look like lamps, but I like to make them big and call them space heaters because A, I'm Canadian and space heaters are kind of a staple of our lives. Yes, it's stereotypical, but it's fucking cold up here. Okay, we're gonna move these in some organized sort of fashion here. Is that equally spaced? Hang on. Yep, equally spaced. Good enough. Now we're going to make them giant and scale them up to like 1.2. One's fine, I guess. And we're going to make them glow orange. So orange is 100 and 0 and 255. Oh, 200 range is fine. Don't need a blink frequency. Turn off. No, we want to give them like 1,000, 2,000 watts of power each. Right? Because we want to create a load for the reactor. That's the point. Now, junction boxes can have 5 connections total, but because we're not connecting to any other junction boxes here today, let's make this look all pretty, like, why don't we? See, I can snap down to like an automatic node, so I'm going to put that one in here. Actually, make this one here, and put this one here. Flat, there we go. Take this one, and go down to here. It just takes a little bit of effort, and you can make something look really nice with very, very minimal effort, assuming you're in its final spot. Because once you have to move it, you're screwed. What did I just do? Yeah, it's not really super pretty yet. Hang on. Put him here. Put him here. Put him here. That way. Okay. See, pretty. Okay. Turn our walls and structures back on because we're not done with the basics. We need a reactor. We need oxygen. And actually, technically, don't need a reactor if you've turned the power consumption off on your devices. We do, however, need a vent because if there's no vent, there's nothing to deliver the oxygen. The oxygen generator just keeps it all to itself. We don't need that. Oh yeah, you don't wire them, you link them with the spacebar. So we're gonna turn our link view on here and see the things I've tried to connect something to the background. So you want to link two things together, you highlight, in this case, the oxygen generator, you hold the spacebar and you click on the other thing that you want to make a link to, and if it's a valid connection, you will have a green line that shows up when it's done. I'm putting, technically I should only need one for this size, or for an open cabinet like this, but we're not going to be encountering enemies. I just don't want to make sure. I like to make sure that we're not going to all suffocate. So, I really hope this audio link is going well. I've had so much fucking audio trouble with this thing. So we're going to, what do we want to do? Okay, data logger, right? Okay. Let's make sure this thing works. We need spawn points. That's the final thing. Okay, spawn points. Oh, we need to give the captain somewhere to be, don't we? Yeah, he can have his own little room in here. I can find him to quarters with the mechanic. Can play cards or something. Actually, you know what? Let's put the vent in here, and then look at that. It was useful. Okay. This goes here. Gotta give him something to do, I guess. So just roam around and do stuff. Then you need a navigation terminal, even though there's not going to be any motors on this thing. Put up here for the captain to be all pleased with himself. What else? The mechanics like working on engines, don't they? So we'll put a big old bloody engine down here. Make it a little bit small. Oh, whoops, it's 2 engines. Mirror at X. Shrinky. There. Now we give something for the mechanic to waste his time on. Okay. So we're here. We've got this. These 2 things don't need to consume power to be fancy and time consuming, so we're going to turn this power consumption down to 0. What am I looking at? What was that? Oh, it's a steering. Navigation terminal. Lighting 0. Because it won't turn on if it doesn't, or if it'll turn on right away if it doesn't actually require power. So let's give them a nice pleasant background because they're going to be in there a while. So let's generic outpost wall 3 sounds good. What the hell is that? Good enough. Okay. Ladders. They need a way to get around. And this whole thing was triggered by spawn points. So we're going to go into... turn those on. I think I've got one already. Yeah, okay. So that's a spawn point. You want to put one here. I'm holding control. If you hold control and drag and drop, then it creates a new thing of whatever you're dragging when you get to let go of the mouse. So this is going to be specifically for the engineer. This one's going to be for the captain, which everything spawns with at least 1 captain. And I think it has to be a mechanic. Oh, mechanic. So that's where they're going to spawn. They've got oxygen. They don't have much to do, but we're going to let them just fiddle around with that. In the meantime, we got to put fuel in the reactor. Almost forgot about fuel. For now, we're just going to put standard fuel rods in. I feel like that's a little aggressive. Okay. Oh, right. Ambient lighting. Fun fact, if you pick a hull and you go into here, we can say, we'll call this white, so 255, 255. Call it 100. It's probably still going to be pretty damn bright in here. Main compartment. I don't know why. It doesn't really need a name. We're going to stick with it, though. What could we call this? The goldfish bowl. No, reactor test. Let's be honest. Okay. We're just going to say, oh, you don't have crew waypoints, so AI can't navigate their way around. We don't have any points for cargoes, and we don't have any pumps that are marked ballast. I think we can live without those things. Computer, you're just vain. Okay, let's see what happens when we start this. Is he drowned immediately? Place your bets. Yes, he does. We didn't put a hole in the captain's room, so I kind of called it there, didn't I? I was being kind of joking, but apparently not. If anybody's in the chat, or anybody shows up to the chat, please feel free to let me know if my audio is working or not. Okay, sorry, that was a yawn. Let's see what happens now. He's alive, and he's alive, okay. Power. Turn on this thing. Right. Those lights aren't on. Okay. That's why the reactor's not doing anything, because it doesn't think it has to. So, let's put all these things on a switch. Actually, tell you what we're going to do. We're going to put them on a relay. And put the relay on a button, because it's going to be useful later on. State out. Notice I'm switching to blue. Set state. State out. Set state. Set state. Oh, I should have music going. Yeah, that's better. Super exciting music for super dry material. Yeah, native auto controller is still laughably slow. Yes, yes, yes. It's a single fuel rod. Calm down. Now what happens? Yeah, you see our heaters turn on. Slowly but surely, our reactor is responding to a massive jump in output. Okay, that's your native controller. Good, it works. Awesome. Okay, now what do we want? We want to do a data logger. Okay. So data logger, we need this thing that we can. Now this thing's a fun little trick, because the color component takes inputs from red, green, blue, and alpha and turns them into a string format, which is the numeric value of R, comma, G, comma, B, comma, A, comma. Or no comma after the A. Anyways, you need like 4 or 5 concatenation blocks to accomplish the same thing. And the fun part is that even though the RGB and A values are all restricted to a range from 0 to 255, when you apply them to a light, that value is not truncated in this set. So if we put 4,000 and then 4.29 million and then pi or whatever in these inputs, it still comes out those numbers separated by commas. It doesn't restrict the inputs to 255 until you feed it into a light. That makes this little block incredibly useful when it comes to data logging. So we're going to go over here. We want temperature out. Oh, hello, cat. Quiet. Ladies and gentlemen, the gaming cat has arrived. Let's see, we want power value out. Not right now, Terry. I don't know what just happened. I blame the cat. Come on. We need fourth value. Yeah, why not? It's not relevant to our interest right now, but we can put it in here just for shits and giggles. Okay, so that's going to come streaming out of there at 60 frames per second. So we're going to stick that into a concatenation block with a memory block. And for reasons that will become more apparent later, we're going to put a relay on that. Okay, so this goes out, puts in here, put a semicolon as our spacer. We're going to make this an absurdly high number. So this is going to be coming, the input to our concatenation block will be the output of our memory component, and that way every time it recycles around in a circle, it adds whatever's coming out of this thing to the bottom of whatever's coming out of this thing. It's quite clever, actually. Oh, that's right, we're going to put this on a, we said we're going to put this on a relay, so we're going to put this in here, signal out, into the relay, signal 1 out, and while we're here, turn it off by default, and in there. And then the signal is going to go back into the relay, come out the bottom, and go back in here. Signals into the input. Okay, so that's going to only go when we push a button. And yeah, okay. Oh, let's make sure that this thing gets some same absurdly. Let's see, right here, big number here. Oh man, I love Infraction. It's got me good music, and it's free. All right. Okay. This little relay here is going to hold our reactor in an off state until we tell it not to. Actually, we do want that on by default. Okay, this is going to be our on-off controller over here. Yeah, I know this isn't really super necessary, but it is important to me to have visually appealing systems. We want a signal check block here. Okay, when output is on, we want 255, no. 255, 0. What the hell is this playing? Whatever, okay. Set color. These guys can be on 24/7, so there's no need to have a set state control. Yeah, it just makes my lights all pretty light. My switch all very easy to tell from a distance what's going on here. So we're going to go in here. We're going to make these invisible, hidden in game. So now they just clutter up our view. Tuck that in there behind that. And we're going to take these wires. We're going to tuck them in back here. And ta-da, we have a light switch that lights up whenever we turn it on or off. There. Perfect. I'm also going to take this into here. We're going to call this into a set state because the switch toggles back, or the lever toggles back and forth between enabled and disabled. Sorry. Yes. What? What did I just find? Oh, there's a second one in there. Yeah, look at that. No, not anymore. Okay. And I'm going to pass a wire directly through our reactor. Seems like a great idea. Actually, no, we don't want it to toggle state. We want that to set state. Otherwise, it'll be constantly turning on and off. Okay. We should probably get some text displays here. Temperature. Okay, it's core temp. That's power. And the other one will be load. Okay, then we should probably label those. Okay. What do you think, guys? Does it work? We'll leave this on. Because that relay should hold it off right away. Oh, hang on here. Wow, the audio. Okay. And load following. Awesome. I'll check this out. We're gonna turn this off. I'm gonna copy and paste all of this text from in here. And let's open up MATLAB. See if I remember what the command is. User local. Oh god, I'm good. That was epic. We don't want this. We want no, you know what? You guys probably can't see this, can you? Okay, let's see. So System colors, text, green, black, black. There you go. Fonts. Where's my fonts? There's my fonts. Alright. Let's just see some testicles. Copy this. Go into here and we say, oh, okay. I got one. We're gonna replace covers with tabs. $5,976 data points, huh? Alright, let's see what happens here. There we go. Okay. Dun, 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 dun. Okay. Test. Column 1 equals let's spell 1, 2 size test 1. Okay, so now if we say plot test column 1, test column 5, which is our power. Why didn't that work? Oh. What's going on? This is... Oh. 3 is what I want, not 5. Jeez. Of course. There we go. And if we say test column 1 is equal to test column 1 divided by 60, then repeat the process. The lower part here is in seconds. So I'm gonna call rename this to shush cat. Okay. Test object. OB is sidekick. I'm just being super future-proofing right now. Target 8,000. What was our reactor's main power? Going back to the editor here. Okay, reactor's power output was max is 20,000. Okay. Max power. 20,000. Oh. Okay, so now we have a thing called reactor tests, and it has individual test events. Okay, so we're going to say save reactor tests.mat reactor tests. That's going to save all this crap to a file that I can use later. Okay, awesome. Alright, now why don't we try some other stuff here, huh guys? That's what you're here for. Well, technically we should get some baselines, so let's do that. We'll do some combinations of uranium. Oh, fuel rods, what I want, fuel. Okay, 2. Okay. Let's see what happens. 2 fuel rods should be slightly faster. And we have load following. Cool. Go back here, turn this off. Go in here, copy this, all this information in here. And then notepad, I think, is where we want to be. Paste it here. Change our semicolons to new lines. Place all. Oh wait, there are people here. Beach drop, nice. I had no idea, guys. I am so friggin' old sometimes. Okay, here we go. Damn, we should really have an actual testing map instead of making them every time. Sorry guys, I'm catching up on the chat here. I missed a lot. Big fan of the art style. Okay, here we go. So we changed, now we need to change commas to, oh guys, I am totally oblivious to the chat until now. Welcome all, JB and Young and Straylock. Cool names, I love it. Give this a second here to sort itself out. Come on. Oh. Don't be like that. Oh, it's thinking. Hang on, where's my cancel? There we go. Okay, 5,121. Okay. Let's copy these over to MATLAB. Okay, so we're gonna say test object, test2, test object. Okay, where's our test data? There we go. Yeah. Oh, it doesn't have, what am I missing? Hang on here. This has been a long time since I've used MATLAB, guys, so give me a sec. Ah, right. Come on, there we go. None, no difference. So why the hell is it giving me trouble? Oh, there's a way around this. Hang on. Struct 2. Table. Input structure is scalar, but different rows. Okay. Okay, let's put them in cells then. Oh, okay. Young says, I'm trying to compare all the different forms of reactor controller objectively, but to do that I need to be able to plot them against each other, so that's what I'm trying to do right now is come up with something that I can use to plot them. Right? Because if I go in here and I say, reactor tests. Hang on, let's turn this back into the table now. There we go. Okay. Reactor tests. N+1. Can I do that? Equals test2. Alright, well, whatever. If we say, plot test2. Where's test2? Oh, that's what I've done wrong. Okay, test2.test data. Maybe it's just data. Column 1 versus test data. Column 3. Hang on. Why don't you try to look at the code itself? Maybe go. It did. I can tell you exactly what changed there. They've modified it so that the inputs to the, like, if you send a change to the fission rate command through an input port rather than through the UI, it applies the change at 1/5 the rate as if you were to move it manually. So everything responds at 20% the rate of what it did before. So I can tell you exactly how the reactors change. What I can't tell you is how the response of the different controllers, because there's a whole bunch of options now, and somebody's come up with what looks like a good one. Oh, I wanted test data 1 to test data 3. No, this is the original, because I didn't timescale the other one. Okay. Test data, okay. Hang on, I have to scale that, otherwise it won't work. Test 2, does that make sense? Hang on, why don't you try to look? Okay, no. Test 2 test data, column 1 was 2 test data 1 divided by 60. That should work. Where's my other MATLAB window? Come on, here and this one. Okay. So let's see if we can compare that. Oh, I can't see my YouTube window. Okay, so we'll say hold on. Plot reactor tests. Test 1 equals reactor. Brace indexing. Screw you. Aha, okay. So this is kind of what I wanted to be able to do. Just this is only between... Oh man, what? How big is that? Oh. Man. Changes to blue, I suppose. Alright, now... Yeah, they moved up at the same rate. Interesting. Or did I just copy the same data over? That's probably what I did. Anyways, we can work on the code later. Right now we've got... here, somebody's asking. Let's see. Let's compare this to the two-component reactor then. Right, reactor controller. And so we'll need a relay here, and okay, so we need memory and 2 greater blocks. Our target temperature, so we're going to say temperature out here. If yes. If this is greater than 0 and 100. So if load is greater than power, turn this on to 100%. And when this is off, so this is 0. It's technically a 3-support component, isn't it? Alright. Let's see what happens here. Okay. Oh, I didn't push it, did I? Yeah, look at how much faster that is. So much better than the native autocontroller. But not perfect load following. Interesting. Interesting. I wonder what's causing that. Okay. What's the other one? There's a couple others out there. Okay. So sad the dev chose to nerf automatic controllers into the ground. It's nice having to pursue other projects and being glued to a UI. Yes, exactly. I 100% agree. The notion of the mini game is not that bad, but the execution leaves something to be desired, in my opinion. I get what they're trying to do, but it's not what's happening, unfortunately. Okay, we're going to put it here because I want to put all my controllers into the same sub. And, no, we can't do it there. Put it there. There we go. If temperature is lower than 5,000. Okay, so if the greater than comes in from the memory block. Yeah, there's a really interesting one that is, it looks rather complicated in terms of you have to also pay attention to which order you place the components in, because that determines the order in which they're processed frame by frame, right? So it seems like a lot of effort. I haven't looked into it. I was thinking about trying it tonight, but it might be a little boring for everybody to watch me learn fumble my way through a new reactor. Okay, it's into signal 2, and then I'll put this in here. That's not straight. Okay. Man, that native autocontroller was pretty terrible. Alright, let's see what Barotrauma Workshop comes up with. I'm going to have to go off screen here for a second. Yes. Just because everybody used to love it, we'll do the 5-component controller too. I know people, it's not as the bee's knees as the 3-component reactors, but I get why people think it's cheating. It's really cheap. But I mean, if you're gonna circumvent the game mechanic anyways, why would you use a 23-component PID controller? Okay, let's see, what's this? We got the 5-component controller. So we need 2 memories, 3 divisors. Okay. This one's 75. Although it changes with the fuel, doesn't it? Max power divided by 100. Okay, so that was, I think, 20,000 to 200. Okay, so load value out to this one. You want I have to break these out into relays. Should have seen that coming. Okay, so this is power out. Is that, or no, I want load out. Okay. Load divided by max power divided by 100, okay. Turbine output. Okay, fuel out. 75. Okay. My goal is to determine the best form of reactor control now after the changes, because I've gotten a lot of questions on my other videos and everybody wants to know what's the best way to control a reactor, and I intend to find out. Make sense? Okay, good. Okay, we need buttons on these. I don't know how to do this. Okay. Okay, I'm going to try to make a little, I know this is overkill, but I'm trying to make a little selector circuit for the which controller you're going to use. Okay, so we want, where's my buttons? Button. What's it? The hardest part for me is that I don't know the equation of bringing. Okay, I'm going to post the, if you go into Barotrauma's workshop, okay, and you search reactor controller, you're going to see I search reactor controller. You're going to come across a bunch of these ones. The first one we're testing right now is in this group. I honestly can't explain the equation. I just found it. It's load following, not power following. So it basically, yeah, it compares what it's producing by load to the what is being demanded, but it doesn't touch the fission rate control seems rather static. But the two are coupled, which is why this one's always bothered me. Oh. Okay, let's get this out of here. Oh, look at calendar. I need to put this back in this window. What? Fine. Don't like 2 seconds. There we go. Shh. Can't you see I'm live? Shush, cat. This will be useful once I have like 3 or 4 or 5 controllers in here. I know it seems silly to do this now, but it's preparing for the future. This one, yeah. So we'll set it for now we'll call it 4. No, this one's a 0. We want this one to be 0. This one is whenever it hits to 4, I guess it'll loop back to 1. It doesn't do anything in between. So when this, nope. So what this is going to do, this is going to connect our counter loop to itself. You'll see what I mean here in a second. That was a fantastic explanation, wasn't it? Okay, so when this hits 0, no, when this hits 0, it'll come back 3. Okay. And we'll connect it to Wi-Fi. Oh, it's going to work out perfect. Because we're going to put this into the text display. Put this on channel, call it, I don't know, 101. Alright, oh, you know what, it's gonna bug me if we don't fix this, so let me give me a sec. I'm gonna take these and just change them down to like 10. Cast shadows. Oh, that's not working. Wonderful. Oh, and they're both on. Oh my god, I love it when shit just doesn't... It's not only not working the way you want it to, it's really not working the way you want it to. Okay, what was going on over here? Why wasn't this coming up? Oh, well, let's try putting this on 1. Okay, when this receives a signal, it should go -1. Moves us down. Okay, this one... It goes connected to it straight. Alright. Uh-oh. There's a problem. No, that's right. That's weird. And it's not working with the wire, with the Wi-Fi either. See, I'm trying to get too fancy is the problem. What's up? Will you save this recording somewhere? Nice to watch it later. Maybe you have a second. No, I'll save it, buddy. It'll definitely, absolutely be saved. Okay, signal check component in. If signal check component is equal to 1, target output should be 1 to set state. Set state here. If set state is this one, it should be... Oh, no worries, man. How do you implement in this game is the code before you turn in the game? Might go all messy. So these parts up here, like I'll put labels around them. These are the only parts that you would build in game. Like I wouldn't want anybody to go building a test rig to determine which reactors are the best, or which reactors to control. This is kind of like a purpose-built sort of thing. This is just for testing purposes. These are the controllers that you would put in your actual ship. All right. We haven't tested this last one yet. Let's see if we can just force it to do so. Is on. See what happens. All right. So this should be testing with the 5-component controller. Go. Look at that puppy go. Ooh, that was a nice smooth roll off too, wasn't it? And the load following seems pretty good. Alright, let's okay. Let's try something a little different. What am I on my relay? Okay. Where's that coming from? It's coming from way over here, isn't it? Not what I want. I want to put an alternating controller in so that it changes the load instead of just a step change, because that's not really what I want. Is it, let's reset state. It's really optimal to make it pitch perfect though. Okay, it's what it's about for me is not necessarily having perfect power control. It's preventing damage to onboard systems by overvoltage, right? Which is why this next part that I'm trying to do here is such a big deal. No, how about an and? Okay, so what this is going to do, guys, I've got a... This thing controls the lights over here. These are the main draw in the reactor. When this relay is on, those lights are on. The thing that's controlling the state of that relay is an AND gate here. Absorb... Okay, I've seen that, but it's, first of all, you can't build batteries, right? So if you want to do something in the middle of the campaign, you can't build a battery. You have to rewire one that's in the ship, and that's usually a giant pain in the dick. So the ideal solution would be something you could do with wiring components. However, you are not wrong that using a battery to absorb over voltage is not a bad idea. Okay, so right now, what is this? We're going to say pulse. No, we want square waves on 5-second cycles. So 10-second period. Yes, unable to edit ship midway is a pain in the ass. No, well, yes, pain in the ass. I fully understand and agree with where you're coming from, but you it would be kind of OP if you were able to modify your ship in game. They should have more control over, like, being able to move stuff, like not walls, but like bunks or fabricators, move them to different rooms. I don't know. Okay. When this lever is on, it's going to activate this relay here. No, set state. And then when this relay is off, it's going to permanently latch this gate open. So this should create some 5-second cycles for our reactor to test with. Here's the thing. I don't know if this... No channel... Oh, that's what's happened. I don't have them... Okay, that's what happened is relay things, they're not working because they're not configured to go in the right channel. I don't get why these aren't working. No, this should work. Oh wait. Adder from either this one or this one. What is this? Yeah, so the signal block, which is a -1, or this thing, which is always a +1. Let's set this to 2 by default. We should see whether or not it's... Yeah. Okay, and... hopefully this is making sense. Guys, if I need to talk more, I know this is a rare thing, but if you think I need to talk more, just let me know. See, there we go. Okay. So when this relay's on, okay. It's mode 2. Let's give it a shot, see what happens. And I know that looks the same, if not better, than the 3 component reactor, but watch this. Okay, I'm gonna go over here, click that. That's actually not too shabby. See, this is what I want to be able to plot. I want to be able to compare the 2 reactors, right? It doesn't make sense to me because most of these are represented as component stuff instead of program. Oh yeah. Yeah, I get what you're saying, buddy. I don't want to learn. Oh wow. Case in point. Boom. Right there. That's what we're trying to avoid, ladies and gentlemen. That is definitely what we're trying to avoid. So just to prevent that from fucking with our tests in the future, we're going to say invulnerable to damage. Okay. That was very interesting. That was very, very interesting. Let's, for baseline efforts here, let's turn... Yes, you know, this is being automatically held down, so... you gotta create a 0 condition, so I'm gonna adjust these a little bit. And if the output is -1. Take it back to 3. Okay. And we'll call 0 is the when we use a native controller. That's 3 minus 1. And what? No wonder that didn't work. When this one is... No, we want this one to be 0 when it hits 4. I think that's what we said. Okay. And then when it's at 0, we'll use that to use the native controller. So those don't change. Awesome. What's going on there? This should work. You push a button, it should change the thing. I wonder what's going on. Weird. Let's try the native autocontroller and the 5-second cycles. Yeah, so here's your native controller, I think. Yeah, it takes forever. Okay. Yeah, that's kind of terrible. And by kind of, I mean the other thing. Yeah, can you say house fires all over the place? Yeah, this isn't good. That would not work well at all. Alright, let's change this to 1 and see how the 3-component reactor responds. Okay. This needs to be a 1. I'm actually going to take the data. I'll just plug in an Excel or something. I'm not going to actually try to record anything strange. What is this? Is this still the... No, it's not. Okay, it's not running that. Okay, hang on. I thought that was really slow for the 3-component reactor. You know what? You'd think that, but watch this, okay? The load following isn't perfect, but it'll be interesting to see how this responds compared to the 5-component controller. Yeah, see, I feel like that dives a lot faster. Okay, that should be enough data. Okay. You test it with a regex component to make fissionate. Dude, that's what's there. The difference between the regex component and what's there now is that the regex component is testing for exactly this. I'm just testing if numerically if it's greater than 5,000. The regex is looking for the string that is any number that's above 5,000. So that's what we just tested. And I think you're right. I think you're absolutely right. It's going to be the more effective one. What is this? What the hell happened here? Oh. What is this? There we go. Yeah, see, this is why I didn't want to use Excel for this. It's way too much data points. I have to write the script and come back to this later. Okay, but I'll tell you what we can do. Yeah, okay, we'll do this the old-fashioned way. You would agree that the time scaling on these reactors, like the reactor interface here, is not... This doesn't change, right? This speed over here. So we're saying, okay. And yes, I just took a screenshot. Okay, let's go over here. So big one is it going to hit steady state between cycles before the next cycle drops? No, it does not. Okay. I feel like this one has a little bit more kind of momentum, you know what I mean? Although there was a little kick up to here whenever the under voltage kicks don't matter though. That's what's weird. Okay. Okay. Let's see what these look like. Okay. Okay, let's start up. Okay. Interesting. There's virtually no difference. Oh, I would say there's a difference. Hang on. Okay. What? That's weird. These waves should be the same length. has certainly changed, but there's almost... The only thing I would say that's different is over here. The bottom one here is your 5-component controller. I would say that it peaks a little bit tiny bit higher here in the over voltage. That's really curious. You know what, we need to do this in a way that gets it to steady state. We can't just keep interrupting it before it gets to its top end, otherwise we won't know. So this needs to be changed to 0.05, put on 20-second period. Yeah, 2's fine. No, we don't want... It's not about under voltage, it's about over voltage. It's about preventing over voltage condition as much as possible, right? Because that's really the only real thing that you worry about, right? No, I love this fucking this thing. Look at this. It's like perfect load following, 8,000 kilowatts, and like barely any reactor temperature whatsoever. Alright, let's see what happens here, ladies and gentlemen. Drum roll, please. Okay, so that definitely hits steady state there. The question is, how long is it going to take? So we don't need to worry about the under voltage curve. So when I take my next screenshot, I mean, obviously between underload. Okay. Here's the big, this is the big one, right? We want to take a picture of this, how long it takes to get back to there. Okay. Okay. Oh, wrong one. Oh, I made it uninteractable. God damn it, that was dumb. I really don't know why these buttons don't work. This setup used to work. What did they change? It's not toggle. So it doesn't matter. Push the button. It should send a signal to here, which sends a signal to here, which combines it. Oh, you know what? I don't know. It doesn't matter there. Anyways, doesn't matter. We look at it go. Oh, that's the thing though. I want to have like 5 or 6 controllers on this before I'm done with it. Alright, we'll let this one get up to steady state, and then we'll take another screenshot when it gets down to, place your bets, folks. Is it going to be better or worse? Oh, that little kick doesn't help, does it? Alright. Well, we could just overlay the two because they're on the same part of the screen, aren't they? No, it's not going to work out exactly the way we want it to. Okay, so which one's... This one's in advance, okay. So let's, this whole layer... God damn, that's close. Wow. The two-component reactor is, like, conceptually, installation-wise, component-wise, much easier to install than the 5-1. It's like literally half as many components and half as many wires. So if their performance is the same, which one's this one? This is... Yeah, this is... Yeah, you can say the two or three component reactor controllers objectively faster. than the 5-component controller, and I will be testing the 7, and I might as well check the PID controller, and I'll check out this new battery over voltage circuit that I've found. I want to test all of these things, but for now, guys, it is 2 a.m. in Atlantic, Canada at the moment, and I am way past my bedtime. I did, however, get what I wanted to get, and that's some final, not final, but like at least a beginning of an answer for people wondering which controller is the best one. So far, it's still the 3-component reactor controller. So, guys, Young Relax House, thank you so much for joining us. I don't know what that guy's name is. Andrew Mostovi? Andrew Mostovi. Cool name. You guys all have cool names. Rob is so boring. Anyways, guys, any more questions before I sign off for the night? I know there's probably a 10-second delay, but I'm going to leave it open in case somebody has questions. Nope. Alright. Okay, guys, you have a good night. Ladies and gentlemen, all my fellow nerds out there, thank you and good night. Oh, where can you watch this video, Flurry? I'll save it to my channel, so it'll just show up as in the videos. Hopefully it'll be beneficial to you. If not, leave a note, leave a comment, leave a poll, leave something, and I'll find it. Don't worry. Good night.